Hello, my name is Connor Elliotson, and today we will be learning how to solve quadratic equations. Alright, so let's start with the generic form of a quadratic function. We have ax squared plus bx plus c equals 0. So normally when we're solving quadratic equations, we're gonna want it to equal 0. Alright, so let's start out with an example. Make that smaller. Alright, we have 2x squared plus 4x plus 2 equals 0. Alright, so normally when I'm going to solve a quadratic function, I go through these steps in my head. The first thing I do is I look to factor out any common factors. So what do all these have in common? Well, they're all factorable by 2, so that's what I'm going to do, factor out the 2. So 2x squared plus 2x plus 1. So now that we have this simpler quadratic equation, we can factor it normally using the box method. Alright, so we put the x squared in here, and we put the 1 right here. So we know that x and x are the only things that are going to multiply via x squared. And we want these two to add up to 2x, but multiply to 1. So would that just be 1, right? So we have plus 1 plus 1. That's x. Alright, so that leaves us with this. We have 2x plus 1 squared equals 0. So now you might be asking me, well, what we factored it, right? This is the factored form, but we want to solve it. So what do? So now what we're going to do is we're going to set x plus 1 equal to 0 to find the x value that satisfies this equation. We get x all by itself, so x equals negative 1. Negative 1 is the x value that makes this equation equal 0. Alright, so now let's take a look at the graph of this equation that we just solved. So we said that this was equal to 0. We found that the x value that satisfies this equation is negative 1. So we come down here, look, there's negative 1. And when x is negative 1, y is 0. So that's what this means when we solve the quadratic equation. We're finding that x value that satisfies the equation. I'm going to try 25x squared minus 81. Now, I'm going to go through my checklist up here. Does it have any common factors? Let's see. Well, it doesn't look like it has any common factors, so we're going to skip that step. 2. Use the box method. So is this factorable? Well, yes. So let's take a look at how. Alright, so we have 25x squared. Oops, 25x squared and negative 81. Alright. This real quick. Nope. Just put 5x, because we know 5x times 5x is gonna equal 25x squared. Alright, so now we want something that's gonna add to 0 but multiply to negative 81. So negative 81, or should I say 81, is a square. So we know that 9 and 9. But we know that one of them has to be negative in order for this to be 0. So this will be negative 9x, and this will be 9x. And these will cancel each other out. So we're left with this and this. This is a simple little trick. It's called difference of squares. Right? This is a perfect square, and this is a perfect square. So when you see two perfect squares and there's a subtraction, we don't even have to do this. We can just take the square roots, right? So we have 5x, not squared. So we have one that's plus, so we have 5x plus 9, and we have 5x minus 9. And that's why it's difference of squares. So now we have these two. We're going to set them both equal to 0. So 5x plus 9 equals 0 equals 0. And 5x minus 9 equals 0. Alright, so now we're going to isolate x. Alright, so we have x is 9/5. And we're going to do the same to this one. Oops, and we're good. We divide, and we have our two answers. I'll write it up here. We have x equals 9/5, and x equals negative 9/5. Alright, so let's go to the graph and check this. So if we look at the two x's, 9/5 is also equal to negative, 1.8. Negative 9/5 is equal to negative 1.8. So these answers are good. Alright, so now we're going to try one last problem. Okay, we're going to do x squared plus 1 equals 0. Now, let's go through our steps. So we're going to try to factor out any common factors. Is there any common factors? Well, there's one, but we can't do anything to it. So now we're going to use the second step. But before we even do that, we should ask ourselves, is this even factorable? No. So when we can't factor the quadratic equation, we use the quadratic formula. Alright, so if you guys remember, x equals, oh, actually before we even do that, let's identify all the variables. So a equals 1, right? Because there's only one here, so a equals 1. B, what is b? Well, b, if we look in the equation, there is no b, right? So that'd be plus 0, so that's 0. C is 1. It's now that we have all that, we can go ahead and plug it in. So negative b, so negative 0, plus or minus square root of 0 squared minus 4 times 1 times 1. Alright, and that's all over 2 times 1. Alright, cool. Now, I'm going to simplify that. So what's that equal? So 0. So we end up with plus or minus. So 0 squared is 0. So we now have 4 times 1 times 1 is 4. But there's a negative, so that's the square root of negative 4. So negative 4 over 2 times 1, which is 2. Alright. So now we have this negative in the square root sign. If you guys remember, we can't really take the square root of a negative number, so we're going to have to use I. So we bring it down here. So we have plus or minus. So in order to do that, let's break it up first. So we have 4 times the square root of negative 1 all over 2. Alright, what's the square root of 2? I mean 4 is 2. Okay. Alright, so we have 2. What's the square root of negative 1? We use I. Alright, so now that's over 2. That cancels out, so we end up with plus or negative as our x. So you guys might be asking, well, what does this mean? Well, I'll show you. So if we go to Desmos over here, you see that on this graph, this doesn't cross the x axis, but it still has the answer, right? We can still plug this in to get 0, because I squared right here is negative 1. Negative 1 plus 1 is 0. So there is the answer is real, but it's not real along this axis. In fact, you have to make a third axis in order for you to be able to see it. So yeah, you drag it out down to here, right? Okay, so let's go back. Alright, and I think that's it. Thanks for being with me today, guys. This is Connor Ellertson.